Okay, good day. I am Mr. McCully. This is Dual Enrollment Pre-Calculus, and this is lesson number 33, trigonometric form of complex numbers. Let's get right to it. Today we're going to find the absolute value of complex numbers. We're going to write trigonometric forms of complex numbers. We're going to multiply and divide complex numbers that are written in trigonometric form. And then we're going to use de Moivre's theorem to find powers of complex numbers. And then we're going to find the nth root of complex numbers. So let's take a look here. So first, our definition: the absolute value of a complex number. If I have a complex number, z equals a plus bi, then the absolute value of z, which would be the absolute value of a plus bi, is going to be equal to the square root of a squared plus b squared. Please notice that I, the imaginary unit, is not in the formula for absolute value, so we kind of throw it out. So what is the absolute value? Now, if you remember from Algebra 2, we talked about the absolute be zero. Start over. In Algebra 2, we talked about the absolute value of a number being the distance from 0 to a point on the number line. Well, if we have a complex plane here where we don't have x and y, but we have a and we have b, then 3 minus 4i would be 1, 2, here's 3, 1, 2, 3, there's negative 4, and so that point right there would be 3, comma, or actually not comma, 3 minus 4i. That is in the complex plane. And so if I want to find the absolute value, it's the distance from the point to 0, which would be this length right here. Now we've found those distances quite often. This is 3. This is negative 4 right here. We have a right triangle. This thing right here is a hypotenuse. So notice this thing looks like the Pythagorean theorem because it is. So in this particular instance, the absolute value of 3 minus 4i is going to be the absolute value of 3 squared plus negative 4 squared, which is the square root of 25, which is just 5. So the absolute value of this one is 5. Since we have square root, most of them aren't going to come out that nice. This is an elementary example. Moving on, the trigonometric form of a complex number. If I have z equals a plus bi, then the trigonometric form is going to be z equals r, where r is the absolute value of that, times the cosine of theta plus I times the sine of theta, where a is going to be r cosine theta and b is going to be r sine theta. And then we can figure out tangent by going b over a, where this is the b value, that is the a value. Now the number r is called the modulus of the complex number z, and theta is called the argument of the complex number z. The product and quotient of two complex numbers. So if I have two complex numbers written in trigonometric form, z1 being r1 times the quantity cosine theta 1 plus I sine theta 1, and the second complex number will be z2, which is the modulus r sub 2, cosine the argument theta sub 2 plus I sine the argument theta plus 2. So if I want to multiply those two, so z1 times z2 is going to be the product of the modulus, and then it's going to be the cosine of the sum of the arguments plus I sine the sum of the arguments. And then if we're going to divide two of them, we divide the modulus and then we subtract the arguments for the cosine and the sine. And then finally, de Moivre's theorem is just an extension of this product rule right here. If I want to raise a complex number z to the n power, then all I have to do is raise the modulus to the n power, and then I'm going to multiply the arguments by whatever that n is. And if you need to see how de Moivre's theorem relates to the product rule, we can do that in class. All right. Finally, definition. The complex number u is equal a plus bi is an nth root of the complex number z if z equals u to the n, where that is a plus bi to the n. And so that kind of comes from, how do we know that the square root of 9 is equal to 3? Because 3 times 3 is equal to 9. So if this is an nth root of some complex number, then when I raise it to the nth power, I should get that complex number. So how do I find the nth roots of a complex number? And so we could have multiple roots in the complex plane. For a positive integer n, the complex number that is in trigonometric form, it has exactly n roots given by n to the r times all of these values, where this k is all of the values starting 0 through n minus 1. Now, the reason that we go to n minus 1 and not to n is because normally if I say there are n things and we start counting 1, 2, 3, 4, 5, we go up to n. But here they want us to start counting k values with 0. So this is the first value, 1 is the second value, 2 is the third value, n minus 1 would be the nth value. Okay, let's talk some examples. Find the standard form of the complex number. So if I want to figure out the standard form of this complex number, what I'm going to do is I'm going to calculate both the sine of 5 pi over 6 and the cosine. I'll figure out the cosine and the sine of 5 pi over 6. So if we go to our unit circle, we have 6 times, let's see here, the cosine of 5 pi over 6 is, I think, negative square root of 3 over 2 plus I times the sine of 5 pi over 6 is 1/2. And so if I distribute the 6 to both terms, I'll get negative 3 square root of 3 and then plus 3i as my standard form of the complex number. That's just me. Just calculate the cosine of 5 pi over 6 and the sine of 5 pi over 6, and then here I am just distributing the 6. All right. Next, it says perform the following operations and leave the result in trig form. Okay, well, we can do that. So here I have a product of two complex numbers that are in trigonometric form. So if we go back and we look at the product, what we're going to do is we're going to multiply the modulus, and then we're going to add the arguments. And so here, this thing will be 4 times 5, and then it will be the cosine of pi over 12 plus 7 pi over 12 plus I sine, it should be a 12, sorry, I don't know what happened there, of pi over 12 plus 7 pi over 12, and close the parentheses out there. So 4 times 5 is 20. Pi over 12 plus 7 pi over 12 is 8 pi over 12. 8 over 12 reduces, you can take a 4 out of it, so 2 pi over 3. So the cosine of 2 pi over 3 plus I sine 2 pi over 3. They have to be the same because it's the same argument. They say leave the result in trig form, so boom, we are done. Similarly, if I am doing the quotient of two values, I go back and I look at the formula that they give me. I'm going to divide the modulus, and then I'm going to take the difference of the arguments. And so here, it's going to be equal to 2 over 4, and then it will be the cosine of 120 minus 40 plus I sine 120 minus 40. And so I can reduce this thing here to a half. The cosine 120 minus 40 is 80 degrees plus I sine 80 degrees. Box around that, can't reduce that anymore. It's in trig form. We are finished. All right, use de Moivre's theorem to find that value there. So we want to raise 3 times the cosine of 150 plus I sine 150. And these are both degrees, they're not to the 0 power. I'll raise that to the 4th power. So here's what we're going to do. Using de Moivre's theorem here. That's not it. De Moivre's theorem, we're just going to raise the modulus to a power, and then we're going to multiply the argument by the power. So in this particular instance, we're going to go 3 raised to the 4th power, and then we're going to multiply that by cosine of 4 times 150 degrees plus I sine of 4 times 150. And so 3 to the 4th power is 81. And then there's still degrees there too. Let's see here, 4 times 150, so 300, 600. So we have the cosine of 600 degrees plus I sine 600 degrees. And technically this is okay, but I think what we'll want to do is we'll want to say that clearly this thing goes around the circle a full time, because all the way around is 360 degrees. So if I go 600 and I subtract 360, now if it went around more than once, you just figure out how many total degrees it would be. So I'm going to end up with 240 degrees. So I'm going to say that the cosine of 600 is the same as the cosine of 240, and just use a reference angle and say that my final answer is going to be the cosine of 240 degrees plus I sine 240 degrees. And if you're unsure about that, we could go to our mode, check that we're in degree mode, quit that out. And if I go the cosine of 600, do I get the same value if I go 200, or the cosine of 240 degrees? And this is me just checking it out. I get the same value both times. So those are equivalent. Okay, so the last one for the day, we're going to find the square roots of 16 times the cosine of 60 degrees plus I times the 60 degrees. And so if we go back to the nth roots, we'll look here. And so we're going to take the nth root of the modulus, and then we're going to go through, and so we're finding square roots. There's going to be 2 roots that we have to find. And we'll plug in, n is going to be 2 for square roots, and then we have to plug in 0 and 1 for these values here to figure out what those roots are. So just so that we don't make any mistakes, let's take this, let's hit copy, let's go back down to here, let's paste that in our window right here. And so if I'm taking the square roots in this particular instance, that means n is going to equal to 2. And so we'll get the square root of 16, and then we'll write this cosine of theta, which is 60, plus 2 pi. So it's 2 pi, so I'm going to write 360 times k all over n plus I sine, and again 60 plus 360 k over n. And I probably should put it, since I already have n equal to 2, we're going to go 2 there, we're going to go 2 there, and then we're going to say where k is equal to 0 and 1. Alright, so the square root, so my roots are these. The first root will be the square root of 16, square roots, S-Q-U-A-R-E-U, square roots. Square root of 16 is 4, and this is our first one. So it'll be the cosine, it'll be 60, and then since k is 0, that'll be 0. So 60 divided by 2 will be 30 degrees plus I sine of 30 degrees. And then our second root will again be 4, but this time, and I may have to reduce it, so we'll put a box around this one right here. And then we'll say and then we'll put it over there. So it'll be the cosine of, let's see here, it'll be 60 plus 1. So 60 and 360 is going to be 420 all over 2 plus I sine of 420 all over 2. And 420 divided by 2 is going to be 210 degrees, so it's still on the unit circle. And so we'll say that is 4 cosine 210 degrees plus I sine 210 degrees. We'll put a box around that one. Say we're done. Okay, so the Star Wars fun fact of the day: Darth Vader, the big bad of Episode 4, A New Hope, has only 12 minutes of screen time in the whole movie, and he made quite an impression during that 12 minutes. That's all I got for today, folks. Have a good day. Bye.